Okay, like is used for pattern matching. For example, you say you might have a database where you have so many, maybe you have 3 or 4 countries that start with the letter L, for example. L, for example. So you have London in the cities. You have London in there. Perhaps you have maybe um other cities that start with maybe Lancaster or any other one that you think of. But so you just want to know, you want to select where the location. This is remove residence users here. Residence is residence country having a users table, yeah. Country, I think so. Residence country. So we have residence country that starts with C or N. Let's say we had Canada, we had which other country starts with C there. And you just want to get only the countries that start with letter C. You use percentage. This So what this does is that it brings out what starts with L and any other letter. For example, if we run, let's say this start, let's use C for example. It's better explained. And we run this, you see, it's just only Canada. If you look at the result here, it's just only Canada that starts with C. So that's why it's bringing in only Canada. Let's say we needed users their username, which is their email, starts with A. You can just change this and say username like A. So it will bring out all the users that their username starts with A. You can see all of them are here now. Yes, the class is recorded. Let me confirm again. Yes, class is recorded. Started recording. Okay, so let's do AN. So now what happens is that perhaps you needed to get a particular user. Let's say the user's name is let's say username is Anne, but you forget the surname and you want to search it in the email, like okay, it's Anne something that you've forgotten. So you just want to bring out maybe all the users whose name who has Anne in their name, like beginning of their name. You can just say, okay, let's use AN. AN now will bring out, okay, just say, okay, let's add another N and see if you have any user that has this. You see, now you can actually spot out if maybe you forgot the email or you forgot the particular user, but because you have brought in this operator, the like and the to match the pattern that you want, you can actually bring out any user that you want. So this is a kind of use case that you use the like query or the like operator, yeah, or like function, anyhow you call it. So that's how it works. Also, you can use it. You can use it at the beginning too. You can use it at the beginning too. For example, you need let's use transaction table now and see something like, let's say, let's still use users table on something that will really make sense. Okay, let's say you're looking for users that actually use only Yahoo Mail. Yahoo Mail, you don't want anybody with Gmail or anything, and you just do that. Okay, just wants to get users with their username that has yahoo.com. So you can actually change this and put yahoo.com. It will bring out anything that is in front and ends with yahoo.com. If you run this username, in where clause? Okay, username. Okay, there's no, it's not in transactions, sorry, in users. So if I run this, it showed us an error that there is unknown column username in where clause. If it doesn't run, you always check for your error, like I said. So if you run this now, it will bring out everyone that has email something at yahoo.com. I don't know if we understand the context here. If you don't understand, please put a thumbs down. Let me go over it again. Okay. So that's what the like operator is used for, to actually match patterns depending on the kind of patterns you're looking for. Okay. Next is for the in. So in helps us check, filter our where based on many criteria. What I mean is that you can actually check, for example, users that are in two, maybe two or three places. It works like kind of or the way all works. You need maybe users in London and Manchester. Instead of you to use where city is London and city is Manchester, which is longer, you can actually use the in operator. I don't know what I use. Residence country, Canada, or Nigeria. So this will bring, let's see which residence country we had. Okay, we had Australia. Yeah. So this in now works in like telling us either this or this. So it bring out users that has resident country in all of them. If you run this now, it just checks those users whose resident country are in. So what this does, it shortens the other part that we use, and what we can say where resident country is in resident country is equal to Canada, and resident country is equals to Nigeria, which is longer. Like I explained before, when you get to start writing SQL more and more, you know things that can make your query shorter, or the performance of your query faster. Because at the end of the day, you want something that is easier and faster, so it doesn't affect the database or the performance of the database so much. So one of those is using this in. It helps us bring cut the long write-ups and just make it simpler to look at and cleaner to write. That's for in. If you look at for departments, for transactions, let's say where bank, I think we have bank in transactions as where bank name, UBA and CUDA. Where bank name, where bank name, let's use CUDA and UBA. So you can see it brings out all the bank names that are in put data from CUDA, and all the transactions, sorry, where the bank is either CUDA or UBA. If I copy this, say a bank name, name Okay. No. Put this again. Sorry. This and this, these two query actually are the same thing. They'll give us the same result. So what this in means now, what this in is doing now is taking out using bank name equals to CUDA or bank name, which is like a repetition. So in case you maybe needed like to list 4 different ones, you can actually put all of them in this bracket and this instead of writing or this or that or that. I don't know if you understand what I'm trying to explain here. I'm just saying us that there are different ways. Each anyone you write anytime, anywhere is actually very correct because there are different ways to write queries and bring out a result when you get familiar with it. Do you understand what I'm trying to portray here, please? Okay. So that's how the in function works. So the next is the between function. Between is used basically for values and maybe dates. This is values and dates. You say, okay, where is between this and this? For example, you can say the question might be, oh, I should be writing the question. Should we understand? How many transactions are between 300,000 and 350,000? So that let's say this is the business question we are trying to answer. We comment this out. It goes as a comment. We are looking at transactions with amount 300 between 300,000 and 350,000. 350,000. So that's just business. Well, how many transactions are between 300,000 and 350? Or list all the transactions here. Let's put it in the bracket so we not will not because we look how many it should just be count. List all the transactions between 300,000 and the amount is 300,000. So if we run this, even need this, if we run this, I think there is something in our statement. Okay, inclusive. Yep. To run this, you can see that the amounts now, you can see all of them from 300, 312, 339, all of them will be between 300,000 and 311, 350,000. So that's what the between is. Just it's used for. Lisa, for the between function, can we also use words instead of number? What when you say words instead of numbers, how do you use words instead of numbers? It can do you have between words? So like I said, it's used basically for values and perhaps dates. Values and dates. The amount is a value. You can use it, you can say, okay, where the date is between 15th. Let's write it. Let's say we're looking for transactions. Looking for transactions. Looking for all transactions within a particular day, selected date, selected dates. Okay, we're looking for transaction, all transactions within a selected date. So now let's say no, no, no. You cannot use that's not how your data is now. You work with how your data is. You can't say 350,000 as words. Meanwhile, in your data, it is in figures. And you cannot use it. It won't no, because you don't add numbers in words. You add numbers in values. And you don't measure in words, so you measure in values. That's it. So, like for example, yeah, let's go back to this. Where dates, okay, we have dates between, so you put the dates down, 2024, 02, and 2024, 04, 03, 01. So this now will return all the transaction there was. I think there was no transaction between. Let's see if I can move it. 6 right result. They giving me empty. 0250. This 2023 is supposed to be there. They giving me empty. From transactions table, let's see. Table 0220. Something is wrong with that date. If you look at, I'm trying to one of the things you'll be doing much in writing queries is debugging. Okay, I'm trying to see transaction table. Okay, sorry guys. For dates, I think you have to put this. Let us see it to showing. That's true. So for dates in MySQL, it's actually, yeah, you have to put this quotation. It recognizes it because it doesn't recognize that. It's only numbers that you don't put this. So for dates and values, when you are doing anything, you have to put this your single quotation marks. Don't need to understand. So for that's how you use the between function for to check between values or between dates. I don't know, we did this together. So I hope you guys understand what I'm trying to do here, or what I did here. Yeah, if you have anything and you can't type it, you can actually unmute your mic and say it so I understand you clearly. Yeah, this was list looking for all. So if you want to count it, you can actually use the count. Like I explained, I talked about how to use the count. You can actually count it. This will count it because you're counting all of them now to show you there are 5,000 between these dates. Let's use the 2023 and run it. 0. Let's make it 2024. 2023. It's supposed to be there. In simple computer, I don't calculate strings. We learn it all. I don't know what you guys are talking about. Same is there. Have what did I change? Hello, sir. Please see your screen. I think it's your network. Any other else? Any other person cannot see my screen. Yeah, you can see my. I think it's your network. It happened to you last week. See? Okay, I'm trying to see something. I think something is being right. Yeah. Okay. But 500. Sir, why the is highlighted as a key in Yeah, it's highlighted as a keyword. It's highlighted as a as a keyword in blue because there is a date keyword in SQL. Understand? There's a date keyword in SQL, so that's why it's highlighting like a keyword. Somebody said, "Will it work with double quotation or just single quotation?" Everything is about try. Let's try double quotation and see. So you see it for yourself. So it worked. Can you see now that it worked? And let us see why this was not. So that's running another query for me. What is running down here? Different from okay, it's on top. 293 rows returned. Why is it returning rows when I'm so I was running another thing, running this thing on top because my cursor was there, so I use shortcut. That's what I see. Okay, that's cool. Yeah, he said, please confirm again that the mic and recording is working. Let me confirm more because sometimes it acts very funny. Okay, it's working. That's fine. Yeah. The other time it stopped because the mic was. So that's just how to use. You can see, you can actually count it. We have 203 rows and transactions that fell between 15th of March and December, 15th of February 2023 and December 2023. So that's how we use the between function. You can just use it for users table. I don't think we have it. Users table, we have fees. Let's use for fees. For fees between 1,000, let's use for that users table. That's transaction. Users table, let's use for there's no value there. So grab that. But that's just what you should know about the between. So aliases, lesson 12, aliases. I think I explained this aliases. Did I? I think I explained it last week. Yeah. Yeah. That I explained that you use aliases, yeah, just to change your in case you want to present it to your stakeholder or your manager and you need him to understand what it is. It might not be the same name that you use on the table inside your DB. That will be the same thing that you push out to your manager. Then, for example, let's just give you guys this. Select user ID, user ID, select user ID, just ID. Select user ID as ID. Select ID as user ID, residence, right? Because I'll share this with you guys. Residence, country, as let's put it as nationality from users. From users, if we run this now, show us the user ID and nationality instead of what is on the database as username, as ID and username. Same with other ones too. So let's just yeah, lesson 13 is joins. Please, for joins, you will pay attention very well. But for those that have not actually um, written query before, you pay attention to joins very well because it's one of the most important things you have to know. SQL. Joins is one of the most important. In short, if you don't know joins, you find it very hard to work in databases. Why? Because most of the databases you'll be working with would have multiple tables and you will need joins to combine tables. Your users data will be in one table, your transaction data will be in one table, your product data will be in one table, your staff data will be in one table, maybe your salesperson's data will be in one table, and there'll be a point where you need to know a particular maybe salesperson, how many users he has done, which department is it, how many transactions he has done. So you need joins to combine. People always say that joins is difficult, but it's not. Trust me, it's one of the simplest things you will ever learn in SQL. And once you know it, you can never unknow it. So you would have to listen, and if I'm too fast, stop me. If you are confused, you ask questions, and so we understand it properly. So joins are used to combine tables. Now we can see that, well, let's take for example, let's look at this table. You can see that this user, this is a user, this is a transaction table. No, let's go to users table. This user now, this user, let's use for example this first user. Let's just find one user. Let me do it. Let me this username in this format. And the user that starts with. Okay. Z Lewis at yahoo.com. Actually, this was a real data. I had to truncate a lot of things. They don't hold me. ZZ Lewis at yahoo.com. Remember that user now. That's the user I want to know. You can see the user ID. Let me copy this user ID. Okay, this user will user ID now. If you go to the transaction table and look at, go to the transaction table, see if you can see. Let me see. Select select all from transactions. Where user where user is it user ID we have on transaction? What do we have? With user ID, where user on the ID equals to this is the name for user. From the user. So what happens is that you might want to combine a table. We'll check it that from the users table and the transaction table. So we have a users table with all our users. Want to make the explanation easier for us to understand. We have a users table. These are our users. Then we have a transactions table here. These are our transactions. So you might want to know, you might want to combine each to know for a part for some the particular users maybe that did transaction, or you want to combine user data and transaction data for some users. So if you look at this our user table now, we have ID, username, the date the user was created, the date of birth, the gender, and the referral code. If you come to this transaction table now, for example, you can just see the transaction, you can see the transaction ID and the user ID. You don't know if this user, for example, this first user now, is a male or a female. For example, like let's take that, that's what we want to find. We don't know if this user that made transaction is a male or a female. How do you know if this user that had made transaction is a male or a female? You have to go check the user in the users table, because the users table is what has the gender. So, for example, this user is now in transaction. Let me copy this particular. Let me go down here. Put it. Put the user ID. I'm copying for that particular user. Okay, this particular user that did transaction, I can copy this particular first user with transaction ID 0041. You can see all these transactions here. 041. This user did, well, checked all the transactions from this user from the transaction table. But now we want to know, is this user a male or a female? How do we check? We have to go to the users table now to check if this particular user is a male or a female. So with that, we need to combine it. Okay, manager will just say, put a column to know to put the gender of the user. You just want to get if this is a male or female. How do you do that? You have to combine this data now, or many people they will take the long route, go search the user, and go check the user ID, take it straight to the transaction to the user table, and start looking for. This is what some people will do. If it's just maybe for one from users, where clause, where user, okay, where ID, user is ID. Run the. So you can see this user now. You can see the user on the user. You can see that is a female. This particular user. If you run from the user, checking the user ID in transaction, you can see how many transactions she made. If we check the ID in users, you can see every information about the user. Let's say you had like 20 users now. Maybe say, okay, let's say users that created their accounts from the user table. Now we have users that created their accounts maybe say in a particular month. Then they want to know in this particular month the users that created the account, how many of them did more than 100,000 in transactions, and how many of them did more than 100,000 in transactions. Now you have to combine here, first of all, to check which users were created in that particular date, then combine it with the transaction table to see how many of them did transactions of that amount. I don't know if you understand, or am I beating around the bush? Do we have a little bit of context of what I'm explaining? Okay, let me explain again. Now we have a users table. Yeah, let me copy this. Okay. We have a users table with all our user data. If we run it, this is a user data for all the users in our database. We have a transaction table. One thing you should always note, please, let me just say this. If your database is so big, always avoid this, what I'm doing here. So let's start from all, because it can, if you have a database that has like hundreds of million, or even if it's 2 or 3 million, it will slow down. So always look for what you're looking for. Always use limits. First, if you just want to see how your data looks like, let's say you just want to say first 50 rows. Let me put the limit there so that, yeah, so it should just give me first 50 rows. Or even if first 10 rows, anything. Always limit when you are using select star in it, please always put limits. So because it's just for you to have an overview of how your data looks like. Nobody wants all the user base in your data. Right before somebody will ask you for that kind of thing. So now it's limited to 10. So I don't want it to, they don't go use select star from users. Or if you have like 1 million users in your database and it starts slowing you down, right? You struggle to cancel. So yeah. So what I'm trying to explain now, we have a user database, and traditionally, traditionally, it's in many databases when they are designing database from database engineers or the people that design databases, they would always they always want to separate tables and put and arrange it properly so that it doesn't look so one table doesn't look so clogged or so chaotic. So they might say, okay, let's put the user's information in one table. So anytime a user registers on your platform, for example, or maybe in your firm or your organization, or they always store their information in users table. Then when these users do transaction, or when they come for anything, or when they buy things, or if it's a store, when they buy things, if it's an app, when they engage or when they subscribe, they enter perhaps, let's say, a subscription table or a transaction table. So most times they are being separated like that. But there is always a key. There's always a link between them, which is the primary key. I explained it when we're doing Power BI. We have primary keys. I explained even in Excel, so I still explain it. So the primary key would be what will link both tables together. For example, in the users table now, we have the user ID. This user ID now is a primary key. It will not repeat. It will be one user to one user ID. So you can never see the same user ID twice in the user table, because this ID is unique. It's like a register. So your users table now is like a register. Then for the database too might have a transaction table. That transaction table now is register of transactions. So it means you might have different transactions from one user. So in that transaction table, the user ID now is not a primary key now, it's a foreign key, because different transactions can come from one particular user. What now means is that in the transaction table, the transaction ID can never repeat. It is a primary key, because one transaction has its own ID. If somebody buys something 3 times, if somebody comes now, purchases something, come back again in 10 hours, purchases another thing, the transaction ID is registered as different transactions, but it's registered from maybe the same user. So what I'm saying in essence is, if you have a user table and you have a transaction table, and in the user table you have the information that are there, that are not there in your transaction table. For example, the date the user was created. In the transaction table, what the table, those that are those that are designing database always set it to be unique. They will say that user ID must not repeat, must be primary, set it as the primary key. Yes, it is always set by those designing database. I didn't take us through how we design. Maybe that you can actually learn it. Most things data analysis are analysts are concerned about is how to query, get information. But if you go learn further just how to create database, what I did there was just upload. If you want to go learn how to create database and all those things, you can pick it up yourself. I'm pushing actually what is necessary. So, so you might have in the users table, we have the date the user was created. But if we check it from the transaction table, we will not see that because that is stored in the users table. Now we picked a particular user, which is this person, which is this guy now, or this girl now. We pick this particular user that has this user ID. And we now, if we run it, you say, okay, let's see every information from the users table that has this ID. If we run this person's query now and check, it will bring out the user with this particular ID, which is leaderholly@yahoo.com. You can see the date she was created. You can see her date of birth. You can see that it's a female. We can see the referral code. We can see all the information about this particular user because we filtered just for this user using the where clause. Now, you want to see transactions from only this user. You can now run the same thing on the transaction table. If we run that query, we'll see that this particular user ID did a lot of did about how many? 1, 2, 3, 4, 5, 6, 7, 8. Let me not limit here. Run it again. Okay, it's still 10. So you can see that this user made about 5, 10 transactions between 2023 and 2024. Yeah, if we have to sort here. You can see. So now, but there comes a time when you are being told, okay, let's see users that made transactions and they were created within a particular point. For example, on your users table now, we have the date the users were created. So your manager says, let's see how many users that were created yesterday have done transactions, or how many users that were created in a particular month have done transaction. How many users are registered in March 2024? How many of them has actually transacted? Now you can come say, okay, I want to check users that were created in March 2023. Now say select star from users where where date created, where date created, yeah, date created between, we're looking for March 2023, March 03, 01, and let's use the same March 2023, 31st. Yeah, March is 31st. 31st. No. 03, sorry. 31st. So let's put our okay. Now this now would give us I want to make it sure. This now will give us users who were created between 01, 03. Let's see. Let me see if very data like that. Check 2023. Okay, there's no 20, oh, there's no 2023. Let's use December. That doesn't go. Okay, you can see these are all the users we had now that they were created on in December 2023. Do you get up to that point? Please let me know if we've gotten up to that point. Okay, another person. Just let me know if you don't understand, put a thumbs down. I can go over it again. Okay, just two people. Others, okay, three people now. I want to know if it's anybody that has not gotten it, let me know, please. Okay, now, okay, good, thank you. Now we have users that were created between 2023 and December 2023, 1st to 31st. And now your manager says, okay, these users now, how many of them have done transactions? You now definitely know that we cannot get those that did transactions just from this users table. So what do we have to do? We need to join our transaction table and see that from these users, the people that actually made transactions. Do you understand what you're trying to do? Do you understand what you're trying to do? Find somebody. Okay, so we want to know from here how many users actually made transactions. So we need to join these using the join to transactions. So what do we do now? We can just say, definitely, we are looking for those that did transactions. We'll just use this, this select star from those that did transactions. Yep. But now we have gotten users that they created this date. I want to know those from these users, how many of them made transactions. This is giving us, let me see, let's filter this. Let's see, 300. Let me filter 300. 300. Much. Let me say, I'm going to reduce it. I want it to be practical a bit. Let's use those that did those users that were created between 1st of December and the 3rd of December. I want to reduce the number a bit. Okay, we have 29. You can see here 29 rows. So we have 29 users that were created in 1st of December and 12th of and 3rd of December. So now I want to know from these 29 users now, how many of them did transactions? So we need to join this to our transaction table. So what do? We have to write the query and bring in our join. So our join will always come before the where. So I will take the where down. And inside here, already, I'm selecting users from, I'm selecting star from users. Yeah. Then I'll bring in my join. What am I joining? I'm joining the users on. So what I'm joining, I'm always join the key that connects both our users and our transactions. And what key connects our users and transaction is the user ID, because the ID of the user here on the transaction table is called user ID. It's named a different thing, but it's the same ID here. It's the users that have their transaction here are the users that have their ID here. So you will know how the column is named. Take that into consideration. You know how the column is named. So we are joining our users on our users table. On our users table. No, sorry, we are joining transactions, not joining. Sorry, guys. So we are joining, we are selecting start from users and joining transactions. Sorry for that. We are selecting start from users and joining transactions. So what do we join transactions on? We joined, okay, and let me make it, so now I'll explain that one later. Let me continue like this. So let me spell it out all together. So you will join our users, select start from users, join transactions on what? You join it on from the user table. Our users ID is labeled ID. So it will be on users dot ID, which is here. You join transactions, you join transactions table to users table using on the users table it is ID, and it's the same thing as transactions. Transactions on the transaction table is called what? Dot user ID. I hope we are not confused. Okay, let me explain it again. So what happens is that we are trying to check. This is where we were. Let me cut this. This is where we were. We are trying to know the users. This tells us the users we have that were created on this date, which return 29 rows, like 29 users. Now you want to know these users that are registered with us, that are users table, did how many of them made transactions? For us to know how many of these users made transactions, we have to join it to transaction table. We have to join it to transaction table. And when you are using join, your join clause would always come, will always come before the where. So what you are doing here, just in plain English, you are selecting all from users and you are joining it. You are joining it to the transactions table. So you are selecting all from users and you join the transactions. So, but now you don't just join the transactions and leave it there. So what we have done here, we have joined the users table and the transaction. But the query needs to know, what do you want to use and join the transaction to the users? Now, for you to be able to join two tables, there must be a column that links both of them. And in this, I explained that on our users table, we have the primary key, which is the user's ID, which is the ID, which is the user's ID here. On the transaction table too, if you look at a transaction table, we have a user's ID, which is the same thing as the ID on users table. Did you get up to that point? So yeah. So what happens now is that you have selected all from the users. Now you have joined the transactions table. But what do you join it on? You now have to tell the query that join it on on what column should be equal to the other column. It means the ID, the two ID column. If both of them were ID, it will be ID. But on the transaction table, the ID column is labeled user ID. So that's why I did this. What I did here was forget about this. Let me comment this out so you don't comment. So what I just did here was I joined the transaction on users table. So what this thing is telling us that on users table, bring the user ID. And on my transaction table, this user ID is equal to user ID. See, this transaction table on the transaction table, the user ID is labeled user ID. On the users table, the ID is labeled ID. So that's why you can see on users table, it is called ID. And on transaction table, it is called transaction ID. That's just what it's telling you. So select all from the users, join the transaction tables using this column, the column that matches both of them. On the users table, the column is ID column. On the transaction table, the column is user ID. But if you check the column, they are like they match. I don't know if you have to understand to that point. Sorry, can mute it? Okay. So what if you run this query? So from when you are done with that, that's when you bring in your where clause. This where clause now is telling us where the date created, where what you need to filter, which is the date created. But there's something you need to know. Any column you are listing in the date table in here, you have to tell the query where the which table the column is. This date created can be in users table or it can be in transaction table. So you need to let the query know that okay, this date created table is in my users table. So anything you are doing here, if it was not star, if we say we want to try to get some columns, any column you are getting, you must state it whether it's in the users table or the transactions table. Yes, so you will please ask. Instead of writing, that we'll get to that. Transaction. Okay. We'll get to that. So if you understand it like this first, then you can actually go advance, do all your tweaks and try to get what you want. So now, if you run once you run this now, you can see that the 20 users that were created between that date, which was just 29, they did 133 transactions. You can see the rows return 123. So those 29 users did 110. I've done 133. So now you can know, okay, these are the users that were created in this date. This is how many all the transactions they made. How did we do that? We selected all of them, all the users from the users table. We joined the transaction table on the column that is unique to both of them. Selected where the users they created is between particular date. I can't zoom in this other part. I don't know. Yes, please, Olabisi, say something. Yeah, sorry. Okay. Aspects where you said want to know detail or transaction. Once you select transaction ID, if you want to know more than one, what will you do? Yeah, that's why I actually came to this. Understand? From there, okay. Yeah, from there we'll push to that because yeah, I was like, if it's one user, somebody can just go pick the user ID and go check it on the users table to see the gender. But what if in scenarios where they are much? So I actually start from this. That's what I'm going to learn now. So now, yeah, let's say for example now you have these users. These users now, you have their let's run this. Yeah, you have all their transactions. Okay, let's say you just needed three things from this. And you select, let's copy this. Let me actually copy this. Joins this. Sorry that I'm doing this. Actually, Okay, so this runs. Okay, so now let's say he didn't just want to get everything. He wanted to get. Okay, let me explain another thing so that it makes it easier for us. I'm going to what somebody said. Now you can use aliases, like I explained. For aliases, if you don't want to use as, you can actually just write it after the query. For example, I can say select star from users you. This you now becomes an alias for users. From join transactions T. So anywhere I write T, it will always know it is transactions. So you can actually do aliases like this. So if I did that, let me copy. If I copy this and I paste it down, okay, let me do this. Okay, so if I can do from users you, instead of me writing it users completely, I just select from the beginning. I put my transaction T. I can come here and say instead of using on users dot id, I can say on you dot id is equals to T dot users id. It makes it easy. Now we've given it aliases already from here, and here too from you dot date created. This is the same thing as this. If you run this, it gives us the same result. So what I just did, I just shortened this. So if this code is very long, this query is very long, I can just be using my u and t, my u and t, my u and t. Do we get? Do we get, please? Okay. Now let's copy this query again and add some other, understand some other things. Let's say we didn't need to get everything from the transactions. We just needed to get the users that did this transaction. Yeah. We just want to get their, let's say, we want to get their ID, their ID, their ID, want to get their username, want to get their their gender. So this is where that gender thing I was trying to explain now comes in. Now you just want to, they told you, then you want to get their amount they transacted. Yep. So username and gender are not in the same table. The ID is from the users table. So I can say u.id. If you run this query like this, it's going to look at the error, it's going to tell you, oh, it's going to, okay, it actually ran. Oh, it actually ran. Why it ran? Because I think it has checked that username and gender and amount are not on are not the same thing on the other table. So it ran. But on if most times there might be a case where you have the same thing, like username is on both tables. So you need your your identifier to know which table is taken from. So you have to be using your aliases. And for amount, it happens a lot, especially with date. There might be dates, or the two tables might have ID as the table name. So it's always best for you to always specify which particular table you are taking which column from. So now you see what happened here now on our database. Our username is in our users table. Our ID is in our users table. Our gender is in our users table. But the amount is on the transaction table. But now with using join, you are able to join the user table and the transaction table. First of all, to get how many users that we created on that particular on between these dates that did transactions, and to know if they were much of male or much of female, like to know their gender too. So this answers the question is how many users created within this it made transactions, and what's their gender. So this answers that question. I don't know if there is any misunderstanding we have with this. Okay, everybody gets it. Anybody has any confusion? So what just happens is that if you have two tables or three tables, you can use joins up to like 4 or 5. You can keep joining tables, join. And you always specify what you are joining it on. If you have database that has 2 or 3 tables and you want to retrieve information from both tables, first of all, you state the information you want to get. You state from the first table, you join the second table, then you specify the unique column from them before you now use your filter you want to get. So that's just the steps. Joins is very, 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 very key. Any SQL or interview you are going to, and you must write joins. You must. It's part of it is part of advanced queries. Joins is very basic, very simple, very easy to understand once you get the concept. The concept is you select your data from where the information you need. Most times it's not always all the information, or you might not be using star. You select the information you need, you select from the first table, you join the second table, then select, you put here, select the info you need, select the info you need, select the first table, join the second table, using the unique matching column. Use the match column, then you use your filter. Okay, so these are just comments. That comment, this comment doesn't run, it's just if you see dash dash, so that I'm adding comments just to make you understand what I did here. So I think I can, let me just explain a second one. Okay, you can also use your joins too when you are trying to get maybe the revenue. Let's see, revenue by, you have on a users table, the users table. You have on a users table the resident country. Now we want to see revenue. Let's find the city with the highest revenue. Now I want to know the city with the highest revenue. So how do we find that? We know that in our users table, we have the residence country. Let me use. We have the country with the highest revenue. Let's find the country with the highest revenue. Or let's say find the country with the highest revenue. That's the business question. Which countries have the highest revenue? So now here would be resident country. Here will be amounts from users transaction. Yes. I'm just trying to match what is in our data. So now the business question is which country, which residence country gives us the highest revenue? We know that in our users table, we have a residence country. But meanwhile, in our transaction table, we don't have a residence country. Nationality, we don't have residence country in transaction. We just have the transaction information. But now I want to know from the users that were in different residence country, which one of them give us the highest revenue? What you do that, we select, okay, residence country is in users. Put our u.residence country, which is this. We now have our amount, which is what we call our revenue, is in our transaction table. We bring it here. Remember, we taught us aggregate. Get the aggregate sum of the amount, which this T is transaction, then we alias it as revenue. This from users U is what is making this particular place understand that this is from the users table. We now get it from the users U, which is what we did, what we said we do. First of all, we select the info we need, which is residence country and the amounts. So we just need the residence country with the highest revenue. That's what we want to find out. So we select the info we need, which is residence country and the amounts. We select the first table, which is our users table. Yeah. Then third, we join the second table, which is our transaction table. See. Now, what do we join it on? We join it on the matching columns, which is on u dot id, supposed to be id, is equals to c dot user underscore, and that's how it's called on the transaction table, id. So when we do this now, I taught us how to use group by. Our group by now, since we have I told us that once you use an aggregate function, you have to bring in your group by. We have to group it by the residence country because we want to know each country, what is the revenue. That's the first thing we want to know. Each country, what is the revenue? And since we want to know the highest, we bring in our order by and bring in our descending. So if we run this now, you can see we just have two residence country. No, I think we had three. We have three residence country, but I think there is no user from Australia who has made a transaction. That's why we don't have Australia here. I think we had in our users table had Australia. If you go check, if you go look at it, extra from it. Residence country. Oh, we didn't have Australia. What we had Australia? Where did I see Australia? Sadly, we don't have. Okay, thought we had Australia then. Interesting. And my eyes are not solid then. No issue. So we had Australia. So now we can see that what we just did, there's Australia. Why am I not seeing it? My eye is not working again. Oh. Let me not limit. Unlimited, it didn't bring out Australia. Okay, there is Australia. Only one Australia. Only one Australia. So I think this person did not make transaction. That's why we cannot see it come out in one side. Yeah, it's this person did not make transaction. That's why his user ID is not the transaction table. That's why we couldn't find Australia here. There's only Nigeria and Canada that made transaction. Yeah, that is still that 300 limit. Thank you very much. So what happened is now we can see from the users table, joining transaction table, we have group by. So now we know the residence country by highest revenue is Nigeria. See how much revenue came from Nigeria, just because it's at the top. We did descending. So that's how we can use our join, to know. If also we looked at, let's say, on the users table, on the users table, on the users table, we had um to check referred and not referred, referred and not referred by. Okay, no, I think next country. That's it. Want to go back because time is. I wanted to see another thing we can use to check. Maybe I'll put it in your assignment because I'll give assignment for next week. So that's basically how we use joins. Now, the you can also use left join. Can also use left join. You what the ID? What I will ask you guys to go read about is the different kind of joins in SQL. The different kind of joins in SQL. Just read about it. It will help. It's just like what we did in our Power BI, where I explained that for left join and right join. For left join, you have to you take all what happens in the all the values in the left table and join it to what you want from the right table. That's what sorry. That's what left join means. So for left join, you just take even all the users that didn't transact. If you are trying to use left join, you can take it will take all the users, then it will only take the users that give the values from where month. Sorry guys. So the way different the way the joins, where was I self? The joins they work differently. Left join, right join, inner join, left join, right join, inner join. It works differently. So what I would just ask you to try out, read about the joins. We'll come back to different how they are used differently if we when we finish running through all this. Not today, when we finish running through everything. So we'll come down and explain where each joins, how to use each joins, and what your data will actually see when you are using different kinds of joins. Understand? So let's pause this joins place for now. Just know that normally using just join will actually give you the result, but most times there'll be some scenarios where you have to specify. You have to give specific kind of joins like linear join and left join. Understand? Let's leave the specifics for now, so I don't show you guys. I've already loaded you guys with a lot. Let's just run through this. But I'll start explaining that left join and try to write queries that will do both of take 30 minutes. So or 30 to 30 minutes. So let's just leave it for now. Yeah, group by and having. Now let me explain the difference between when you're using group by and when you use having. Two of them most times can actually want to give you the same result. You can actually use two of them to give you the same result, but most times, but what you have to know, sorry, is that you use group by before grouping and you use having after grouping. Both of them are filters. Group by and having are both are both where and having are both filters that you can use. But where is used before grouping and having is used after grouping. Let me use as example so we understand better. You see, okay, you are trying to get, let's not use departments, this amount, transaction data, bank name. Let me use bank name, amount from transaction. So we are grouping it by bank name. Okay. So we run this having sum of greater than 100. If I run this now, what this is giving me is giving me the banks that have, I think this is all the banks of, let me 170,000, 175,000, or million, sorry. Let me use 170,000. Okay, 180 million. 180 million. Follow me, please. If I'm running this, what I'm running is that, yeah, I just want to know the bank that has their total transactions more than 180 million. And we can see it's just two banks from our list. All of them have, but only Kuda and Money Point have their transactions more than 180 million. Now this having now is a filter. This having now is a filter. So once you want, when you want to use your aggregates and you want to group them, but you want to filter after you have grouped, you use your having. I don't know if you understand. Do you understand? Thumbs up or thumbs down? Any other person understands? Okay. On any other person? Okay. Okay. I think there is a mix. Okay. Let me explain it this way. So what happens is that when we talked about filtering our data, we used the where clause. We use the where clause. But most times when we want to group our data, when we want to group our when we want to introduce a group by, instead of using a where, we'll now use having to filter. Like I said, where and having are used to filter data. But when you're having aggregated data, once you aggregate data, once you bring in an aggregate and you want to filter, you would then use having, because definitely once you are bringing in an aggregate function, you will introduce your group by. If we just wanted to know, um, if we just wanted to know, let's say, um, transactions more than of where amount equals is greater than. So we just wanted to know the user IDs, yeah, where that has amount greater than, that have done transaction greater than, sorry. We just want to know transactions that have amounts greater than 400,000. You can sort this out like this, filtering it using the where clause. But but when you bring in an aggregate function, when you bring an aggregate function and you want to filter, you have to use having, and the having would always come after the group by. Sorry, just give me 1 minute, please. Sure. Ready. Okay, so let's see. Mhm. You see, this, if we are trying to be smart, we are trying to be smart, and we do this. Coming. Okay, sorry. So I was trying to show you what some people might say, oh, why don't we do it like this? Or why do we do it like this? So what I'm trying to explain is that once you bring in aggregate function, the where clause will not work just like this. So you have to use the having clause to filter. You have to use a having clause to filter. So the you group the transaction. Here, what you can do is you group the transactions by user first before we use the having clause to filter these aggregates. Understand? If you are trying to use a where clause with this kind of query, then we need to maybe write it as a subquery, which would go into later. Or we can bring in a where clause. But what I'm just trying to say is that when with the group by, having always comes after group by for filtering, but where always come before grouping when we are not using an aggregate function. Do you understand? Do you get it? Hope we get. Hope we get it. Yeah, same thing with maybe we are using another aggregate function like average residence free. Then we need the average amount, and we need it as average revenue. Average revenue from users. We can use it with the joins too. Join our transaction on user.id id equals to transactions.user id. Yeah, please say something, Mariam. No, the table that you've joined is in your query, not on your database. Yeah. The table that you've joined is on your query, not your database. You are joining it. It's just the result you are joining is not a table on the database. So what can happen is that there are scenarios where you can actually create there are things you call views. Understand? You can create materialized views, you can create views, you can actually create some temporary tables like that and store it. Then you can actually run a query on it. You understand? And we'll get to that where we create views, use the views to continue running other queries. We'll get to that. Group, yep, you're welcome. Group by residence is average. So this too is part of things I mentioned as an okay, Nigeria. So that's just about um joins I'm having and where. Let's just finish. It's just remaining three. We have how many minutes? We have like 10 minutes. Okay, let's jump case first. Let's go to limits. For limits, instead of you to put your limit here, you can actually put your limit inside your query just by writing limit. Then maybe you need the the user with the highest transaction. You select start from transactions, order by amount. You need the top three users with the highest transaction. You just put limit 3. This gives you top 3 because you have done it descending already. I think that is easy to get. Just put limit 3 or limit 5, or depending on what you want to do. You can say users with the lowest age and all those things. Don't have age. So, do we understand the limit? You there? Okay. So let's go to subquery. So heavy. Okay. For subquery, thinking I should leave subquery and case. Which one I should leave? Just finish. Because we need to have another class that will make us good. Should we continue this subquery and this case? I don't know. I don't want to overload you guys. I don't know. Should we continue or should we just stop here and continue by next week? I'll definitely drop this video, drop this, and drop by next week. If you're done with this, next week I'll drop an assignment project for you guys to run through. I'm looking if I can push this subquery subquery case, then types of joins, then views, and treat these four things in the next class. Because understanding joins, because understanding joins alone might be that you guys need to understand it. Use the week and run through what we have learned. So these four things, types of joins, the views, then subquery, and the case. Do it. Round function, round function. Most of those you can actually talk about. Yeah, that one is just straightforward though. So, guys, please, if you say we should do it next week, please just give me a confirmation. Let me know. Okay, that's fine. So I will drop this for us to run through, look at it. Then next week we'll continue from there, and we'll round up SQL by next week. Then I'll give us you run a project or give us a project in SQL. Like I think I've already prepared the project, but you're not fully prepared. It will contain everything we have learned. It will be a business case where you answer questions using queries. I'll ask all the questions. I'll give you a script that you download, and you just take the business case, state what the business is looking for, then you run your queries yourself to be able to see if you have actually understood what learn and how to keep yourself. Then also, when you are done with the video, you can check SQL on W3 schools to help you a lot. I believe most of you might have heard of it. W3 schools. Check their SQL. Let me see. Okay. So you can this is the link. Yeah. So it was it they will also help you. They break down their stuff very well. So yeah, go to W3 schools. That's through the link. Once you can, it will also help you with the class. Go to SQL, then follow it step by step. There are things that might have jumped here. There are things that I might have jumped here, and you go through it, you understand. I'm trying to make you understand. Okay, these are called wildcards. Yeah, I talked about wildcards that we use. Like we use wildcards. Input as wildcards. I talked about the like function. They are called wildcards. This percent. So once you go through, you see everything you have learned step by step. You have some follow up stuffs to help you run to. So if you can do this, you will understand. Forget, don't go to don't. You might not worry about the database part. Just what to worry about. That will help you to just this part, this SQL home part, all this SQL join. These are the joins to inner join, left join, right join, all those things. So look at it too, and just to get additional knowledge and look at it from a different point, from another perspective of learning, to help you, to really help you. You don't learn from one source, you learn from different sources. Teacher would always say, no knowledge is true. Any knowledge you get from anywhere is an additional understanding for you. So we'll end here, guys. Thank you very much. Don't know if you have any question or any comments before I close. So today we'll start from case statements. Case expressions. The case expression is used to define different results based on specific conditions. SQL statement used to define different results based on specific conditions. The way it does it that the expression goes through conditions and stop at the first match. It works like an if then else statement. So once a condition is true, it will stop processing and return that result. If no conditions are true, returns the value, the else clause. So if no condition like this, else clause now takes effect. What I stated here. And if no conditions are true, it returns null. It's better explained in example. What it means is that what it means is that if you start with a case, once you start writing your query, for example, they tell you, okay, manager or your stakeholder tells you, you need all the transactions that the amounts are 400,000, 300,000, and yeah, and low. So what it just wants you to specify in another column. Most times the case statements would be a values in another column. You have to create a new column to publish this case statement as what it is, as what is one is needed. So they're like, okay, we need a special column that if the amount is greater than 400,000, let it show that it's high. So it's just like to categorize, in sort of categorization in a new column based on values from another column. So in this case that we are looking at here, they brought in the case statement and say when the amount is greater than 400,000, put it high. When the amount is between 300,000 and 400, then put in medium, else put it low. Then this enders is the name of the name that you call the column. The case statement always come before the from. So it comes as part of what you want. For example, in this query now, ask to find the transaction ID. You have to categorize transaction into high, volume, and low. And they will always give you like, okay, let it be that if it's from here to here, call it high. It's from this amount to this amount, call it low. It's from this amount to this amount, call it medium. For example, now MTN, a network company, say for Nigeria MTN, or for here O2, for UK O2, they want to categorize their customers into high recharging customers, low recharging customers, medium recharging customers. And I'll say for those who have recharged up to 400,000 in a month, call them high recharging customers. For those who are between 300 and 400,000, call them medium, and we need a list of that. So as the analyst now, you got to write a query to retrieve that information the way it's wanted. So in that scenario, use a case statement to specify, okay, if this amount is within this range, call it high. If it's within this range, call it low. If it's within this range, call it medium. So that's why if you run this query now, you see the results. You see that what it wanted here was it brings out three columns. What they wanted here was transaction ID, the amount, and the amount category. So now they said transaction ID from 400,000 high. You can see all the ones showing low here, if you can see, is below 300,000 because that was what was specified in the case statement that if it's not high, as in above 400,000, or if it's not medium between 300 and 400,000, then it should be low. You can add as many conditions as you want here. Once you say the case statement, anything you want, you can add. Anyhow you want to specify them, any category you want to put them, do it. Then you end it and give it a name. You now choose where it comes from. You can go ahead to write, do other joins and everything from there. So that's what the case statement does. It's used to define different results based on specified conditions. You have to specify the conditions using when. Once you write the case, you state the conditions using the when. Yeah, then you put then it works like an if then else statement. So just imagine this case as if. But in SQL, you don't call it if here. You use case. So if when this amount is then, it's just like it works like an if then statement. Once you finish the statement, you now say else, call it. So I don't know if I've explained it better enough for us to grab. Yes or no? Okay. The same another example from the users table is this too. So for this, you see, we have to find the ID. This is categorize that based on the. So most times, if you go to bank, if you register with a bank or want to open a bank account, or maybe an account that you use for some maybe payment gateways and all those transactions, they always do what they call KYC. KYC is like, okay, we want to know our customer. In those KYCs, they will ask you some personal questions like your address, and other things. So that's like, they call it know your customers. A lot in fintech, it's a normal thing in fintech. They must always do it because of policies and regulations. So that's what they call KYC. And most times, in most those kind of companies, like I've worked in the fintech that does that before, and this KYC is always very, yes, I'm recording. This KYC is always very, very necessary for them to be able to, for the company to be able to keep track of their customers that are failing. There is what we call funnel analysis. While I know you might have heard of it, and in some places, you might learn of it later. Some people, you might have looked about them, read about it, or see it somewhere. There's what we call funnel analysis. Funnel analysis now, it's kind of an analysis to be able to understand your customer's journey, and to understand where your product or your marketing or anything you're doing is failing. For example, it has the acquisition side. Acquisition side, where how many customers you acquired. After the acquisition, we have the activation. We have the activation. These customers that we have acquired now, have they registered? The activation is the point we do the KYC now. You know that, okay, this customer has been activated. Then we do the retention, the retention, yeah, referral, and like any stage you have to call it. Like it might just be your funnel might just be from from when the customer came, did they complete their profile? It might be the second stage in your funnel. Third one might be, have they done a transaction? So it shows you how many customers, percentage of customers that did something from the others. So most times, this KYC in analysis can also be presented in form of funnel analysis for you to know, okay, I had and we had 100, this for our KYC. If you want to do analysis if it's working or it's failing, you have to know how many customers started the KYC. Maybe starting now is them filling the form or them landing on the the KYC page. And the KYC page now might contain their full name, their phone number, their address, their occupation, like details. You want to collect their details, like you want to know your customer. That's what it stands for, KYC. Know your customer in this instance. So now some of them might start and stop somewhere. They go off because perhaps your form is too long. Some of them might complete. Some of them might start but instead of them to be to be approved by a system, it shows failed. So that's how I specified all this. That if you look at our transaction, you look at our transaction table, full transaction table, you see that we have where we call is KYC verified? Yes or no. We have KYC status. But our KYC status now in on our table is shown in numbers. Most times, most times in databases, they use numbers to represent a particular thing. These numbers we call them enums. Enums. So that we see, we call them enums in SQL. So these numbers now are enums. It means that they actually stand for something. This KYC status. So your database admin or your backend person might just tell you on the KYC status column, if you see one, it means they have started. If you see two, it means they are on review. If you see three, it means they are on pending. If you see six, it means they have failed. But they will not store it like that. They will just store it as these numbers and keep the register somewhere. So they are called enums. You just ask, okay, if you are just starting in a new place and you see a database like this, you see maybe KYC at the right, you can ask your database administrator or your backend person that give me the enums for KYC. They'll just give you the what all of them stands for. It's you now as an analyst, because if you are doing an analysis for your boss now, you won't give them this number. Them they don't know. This is the technical side of it. It's you now that will actually change these numbers to what your business people will know. I don't know if we are getting up to that point. Hope I'm not mixing up everything. I'm just trying to explain the concept so you guys understand it in real world cases. Okay. So it once you go to databases, you see a lot of one, two, three, you see a lot of them. So most times, you that is the analyst will be the one now when you're analyzing to business, because the whole duty of an analyst is to be able to come to make technical things easier for non-technical people to understand. So all this your SQL you're writing is just for you. Your own is to interpret it to make people and make the business get better insights, show them the opportunity and the risk. So if you see in this case now, just like your boss asks you, how many people, let's see, KYC process or progress. Are people really starting? Have they completed and all those kind of things? You now you go to your database now. You see, okay, KYC status. You won. You ask your backend person or your database admin, like, okay, what does give me the enums for KYC? They will give you this. So you now use it and formulate it. You can use it now to formulate a a, a query now just to get your KYC distribution. So that's when case can actually come in. I say, okay, you tell the database now, anyway, C1 started. Anyway, C2 means they are pending. Anyway, C3. So that's one of the use cases of case statement. That's why you write this, you run this now, see that from now you can see the IDs of people that are started, pending, failed, completed, and the rest. Don't know if is that um okay. Like, do we understand? Okay. So yeah, one thing which, yeah, please, Edmond, say something. How do you change it? You want to change it on the database? Yeah, yeah. So what is on the database? Yeah, is the 1, 2, 3, 4. For you now to be able to tell business people, okay, we had maybe 50 people on started, 20 people on, and you want to give them that as maybe in form of a report. You want to export this in CSV. You won't give business people 1, 2, 3 because business people don't know this 1, 2, 3. Yeah, that's why I told you. Once you go into a new place, yeah, and you see all those numbers because you see a lot of them. They are called enums. So you now tell your database admin or the back end people or anybody, maybe a senior analyst that was there. Most people they always have it. They are the ones that the people that build the database. They are the ones that actually gave them these numbers. So they will give you maybe a sheet of all the enums. Yeah, I just tell them, give me a list of the enums. They'll give you a list of, like when I started in my former company, I told them, give me a list of all the enums in data. So the senior backend person just sent it to me. So I just use that from that list. They'll always tell you one is this, two is this. It will tell you in transaction table, enums in transaction table for KYC status. One is this, two is this. They'll now tell you for if another place has enums too, they'll tell you for this column in this table, one means this. So you get. Yeah. Oh, yeah, yeah. You're actually making sense. So let me get you. Do you want this particular script? Okay. So what yeah, what will help you? What will help you? What will help you? You know, the purpose of the teaching is for you to understand the concept. Because at the end of the day, it might not always be, might not it will not always be the way it is written that it will be written again. It will not always be the way it was written. Okay, I know you can actually manipulate, but if you don't understand the concept behind it, it will be difficult for you. What I mean is that if you're looking at, if you say, if because somebody comes with a business question that they need to know the KYC distribution for our users, they'll just tell you tomorrow, Edmond, give me the KYC distribution of our users. It's you that will decide that will know what you will use to get that information. Your database might not contain, the use case might not be for KYC. The use case might be for to check amounts, just like I did here. So, but just know that just know what a particular function does. If you understand what a particular function does, you can use the use case now doesn't matter. So what will always change will be your table, your columns and everything, and what you are looking for. For example, someone can tell you, okay, from the transactions table, give us if highest transactions, if the highest transaction is like 500,000, let it be called high value users. But get me for only users that were registered in January. So so then yeah, that's it. So first of all, you have to play in your head what you are looking for. That's why when we started from beginning, I said something. I said the first thing you have to do in SQL is to know what you are looking for, which is the select. So you have to know if they tell you anything they tell you, this is what you are looking for. The first thing you have to know is to know what you are looking for. That comes in your select statement. Then if any other filters that come at the end or any other conditions that come, all those ones are conditions because they always tell you, for example, um, give us users that maybe okay, give us users that registered yesterday. Yeah, already now, what you're looking for now, you're looking for users, right? So from now, the condition now falls on yesterday. So that condition now would enter the where statement. Already, you know where your users are in your database. That will be the from place. So if they tell you now, give us last week transactions. Now you're looking for what you're looking for now is transaction. So the first question is to ask yourself in SQL is what am I looking for? They say, give us transactions from last week. You now say, okay, what I'm looking for now is transactions. So now the other thing they will add is that, okay, for the transactions, you don't need the whole columns. What and what information do you need from transaction? Just give us their full names and their email. You understand? You now, okay, now you're looking for the full names and emails of people in the transaction table. That is the what. Then now they now say, give us users that did transactions, but let the transactions be the one lesser than 200,000. That is a condition now. So you have to know what you're looking for first. Then the conditions. Once you know the conditions, then you can actually manipulate. You can actually know how you write it. So if just have to get the foundational knowledge, because me giving you this script, it's not like if have you seen people have written queries that are up to like 100 lines. I'll give you guys this script after today. I'll give you guys this script after today. You're welcome. Okay, any other person, or do we understand? Thumbs up or thumbs down? Okay. Okay, thank you. So there will be other. I would attach. I would have an assignment here. So you just use it like asking business questions. So these are straight business questions that you just answer using some of them have done it, some of them have repeated it. And let me explain something that I missed. I didn't want to say from beginning. I didn't want to say from beginning. Short, let me wait. I will talk about it later. So we we have done case now. I hope you have understanding. But one thing with queries is just like code. Short queries are code. If you stop writing it, you will forget. You only get better by writing it. That's one thing with queries. You only get better. So I used to tell people if you can spend, even if as this lowest as 15, 20, 30 minutes a day, just to look at how to just write some queries, the more you do it, the better you get. 30 minutes a day or 15 minutes, because SQL, as far as data is concerned, is very, very in data engineering, data analysis, data science. You can never run away from SQL. So the more you write it, the more you get better. It's no matter how it happens to you tomorrow, it will always be relevant. Okay. So we have done limit, not the limit. So we go to subquery. Okay. So what are subqueries? A subquery is a query nested inside another query. It's a query nested inside another query. It's query inside a query. So think of it as a query within a query. What happens is that the inner part, where the inner part runs first, find the specific information that the outer part needs to finish its job. So subquery, just like a query inside a query. So I stated that in data analysis, subqueries are used when you can't get your final answer in one single step. So what happens is that the inner query now acts like a helper, handing off its results to the main query. So what it does is that the inner query runs, then the result from the inner query now use it to run the outer query. We'll explain it when we get to this. So how it works is that a subquery usually it's inside parentheses. Yeah, remember that. So the computer processes the code in this order. So it runs what is inside the parentheses as a different query, then it runs the outside. With the result now, it uses to run the outside one. What happens? The inner query executes the code inside the parentheses first and holds that result memory. Then the outer query takes that result from the inner query and uses it as a filter or a value to complete the final reports. Okay, I think not too much explanation. Common ways to use it in a filter where clause to in a filter where clause used to find rows based on a dynamic value. Then that's, for example, this is where we use a subquery, finding all transactions that are more than average amount. For example, now a common interview question, in SQL is always find the second highest transaction value, or second highest anything. Those are very good places to use subqueries. This are example. It's like that. It's almost like that. It's a finding all transactions that are more than the average amount. So what your boss just comes to you and tells you, our average visitors, the average visitors we have to our healthcare, our hospital these days, we have like we have like 300 patients in a month that visit us, that visit the hospital. 200 patients in a month. We're like, okay, are there any months that the number of visits was more than this average? That's a typical business question. The owner of the hospital wants to know, okay, from January to December, we've had, with the average, we've run it, see some months 320, some months 300, some months 350, some months 280. Then you run the average per month. You say, okay, average visits by patients per month is 300. They now want to understand, okay, that 300 that we've said that I have average now, are there some months that are more than 300? That's a very good scenario to use subquery. What does the subquery do now? Subquery now brings in, it runs inside the parentheses like we said, this parenthesis now. The, are you confused? Are you good? Okay. Inside the parenthesis now, we have, let me bring this down so that I don't think it's joining. We're running just this code. See, inside this parenthesis now, we have a select statement. This is a full query on its own. Select average amount from transactions. That's how we used to find our average. Let me run it here. If I run this particular query now, this is a full query by on its own. You can see that average is 248232. Forget this thing, this decimals. So this is our average now, 248,000 on average, the amount for this transaction. But now they say, okay, how many transactions do we have that their amount is greater than this average? How many months do we have that the users, that our patients visit more than the average we have in a month? That's just one of the cases. So you run the query inside the query. If you run this, what you're doing now is, this is the one inside parentheses you first run. Once it runs and gets the result, what it gets as result now, in this case, the average amount is what is the result. So what this query is just telling us is, select from select all from transactions where amount is greater than this. Let me do something here so that you see a pretty clear knowledge. Okay, let's copy paste here. So these are two queries now. See this, these are three queries. These are three queries now. This one now, it tells us the average amount, which is 248. Now, this one, if I remove the whole of this one, maybe if I had run this already to know the average amount, I can just take the figure and remove all these ones and put 248,000. So this query and this query, same thing. I don't know if you understand what I did here. Okay, yeah. So this query and this query are the same thing. But let's just say we didn't stay to run this one first or write two queries. We just said instead of writing this one, what gave us this result was this is the average amount. So we just take it, we want to use it as a subquery now. We just put in brackets, say give the result of this, put it use it to run here. So that's what the subquery does. Is a query inside a query. The explanation is not bigger than that. It's very simple. Very simple. So that instead of it, and another thing we should know, subqueries can also be used in place of joins if it's easier for you to write it in place of join, in place of combining two tables, you can use a subquery. I will show us later. But let's just understand that what this subquery does, it is like a filter, just like we stated here. In a filter where clause used to find rows based on dynamic value. That's what we did now. So instead of it to use the where clause, where this is greater than this, just put greater than, write the subquery that brings other result. Then another thing I just stated, that you can use a subquery as a form of combining two tables. For example, in this query, we want to find the details of users, that have done transactions with First Bank. So now if we look at our table, we can see that some users did transactions with First Bank. Where is my You can see that some users did transaction with First Bank. But now those users, now we don't have their details. So we want to combine it with the users table now to get the details of those users. What I mean the details are maybe like location, all those things are stored in the users table. So instead of it to use, we can use a join to solve that. But instead of us to use a join now, we can use a subquery too. Use a subquery. What does a subquery do? So you're using where and in this case. What you do is that you see this select distinct users from transaction where bank ID is first name. On a normal day, you can run this one, get this result. But if you get this result, you now run this other one too. But why the heck? Why don't you just run it as a subquery? Say, okay, you can start it like select, for you to always get it clear, perhaps you can start it with select with this other one. What you need to do is to get all the users from transactions where the bank name is First Bank. Then you now say, okay, what they're looking for is the details of those users. So now this is from transaction table. But you need the other details of the users. So now you said, okay, give me all the details of users where their ID is in this list. So now you see we have combined two tables. We have combined the user table and the transaction table using a subquery. I don't know if that's a bit understood. Do we get? Oh, thank you very much for that. This thing. I think when I was writing it's equal to, not greater than. Thank you very much. If I ran it, I would have seen it. Thank you. So you see, where bank name is First Bank. I think I used amount before. That's why I. So if you run these details now, this query now, it shows us that all the user is a bank name transaction, no user. Yeah. So let's start from users, where ID. It's something wrong with that. I don't think there is. I don't think to give us an empty table. Not supposed to be. First Bank. Definitely. So I wrote the okay. Space. First Bank has no space. Has to space. Sorry. Another thing you need to one of the toughest parts in writing queries and most times is always debugging. To be able to debug and see where your issue is coming from. Because if I'm not if that's why you need to be familiar with your data. If something is off, you should know that there's something is off here. Something is off. I will my call any 15 minutes. You know that something is off. If the call ends, please just join again. I don't know. Thing. So I don't know. That explains what happened. So now we can see these are the details of all the user from the user table where they are where the where that banked in first in that use where their bank name is First Bank. Does is it clear to us? Okay, very much. So the next thing we'll look at, okay, this one is not under any lesson. Let me just explain this to you. There is an there is a function called timestamp difference. Timestamp difference. And there is a syntax called current date. So what I wanted to use on is just wanted to find the age from the date of birth. You know, sometimes you might want to do things with your age, with the age of users. That's you want to check users within this age. You can convert your age, and you can convert the date of birth to age using timestamp difference. Run this now. Let me put date of birth. If I run this now, what that function will do to show us the date of birth of the user and the age of the user. So I just put this, I just slot it in here. It's not under any lesson. Just for us to know most of these things. If you just want to do something, you can browse them. Yeah, you get the teaching material. You get it. I'll share it when I'm done today. So that's why I just brought this. You can actually use it to know the age of our users. Perhaps your manager said how many of our users are within the age of 25 and 30. So from there now, can start can start tweaking your query anyhow you want it. Say, okay, what they're looking for now is the count of the user ID. Then you don't need date of birth. Isn't the count of the user ID? Yep. So from users, now put where put age that is greater than 33, 35. Yeah. I think this will need this should need a yep, age in where clause as a this one want me to mm, is where age we use have a Use having there. Need to be video log. What did I do? Let's come. Aggregated query. That's fine. No, we have to use it because of. So we have to use group by users having age. Now run. Okay. Why is that not running? Oh, I thought I've used it already. Hmm. All right. Bye. Now run. Can't group by. Not right. Can't group. What right? What should I group it on again? No. Just give it an alias. That's still guys that are using SQL. Let's give it. uh, and it's just sweet. What does it do? I need to start grouping. Look at it. I want to form my hand. Yeah, so I'm just playing around so you understand how to debug, learn how to debug. So a lot of issues will happen when you are just play with queries. The more you get to play with it, the more you understand, the more you understand better what you are doing. You guys can see where I came from. Started from trying to see if I can use where clause didn't work, and I know where clause cannot work with because there's an aggregate. If we jump from there, say okay, let me use having clause. I'm putting my having clause without using group by. From there now, and answer that, and I say okay, not use just having without group by, and now introduce my group by. But when I brought in the group by, brought it by with try to group it by count ID, it didn't work, and then I had to group it by age. I had to change it to age. With that small play, you can actually see what just talked about debugging of queries. And you know the funny part? You know the funny part? In interviews, that thing I just did now, I can just use it to just score a point. Many people will just sit down, just write it straightforward. Or sometimes I can just do it, just okay. No, 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 this doesn't work. Most times, all those recruiters, because I've actually done one SQL technical interview, and the recruiter was like, I like the way you were talking about the debugging. I was just playing around with, okay, yeah, this will not work. Let me put it this way. It was like, yeah, he likes the way I was communicating and trying to understand what I'm doing. All those things is packaging. Packaging. If you know what you're doing, you know what you. Okay, guys, did we get what I was trying to do here? I was just trying to, yep, get the. So even with some simple queries, even advanced queries, this one is even a very simple query. When you go to advanced queries, you start looking at your debugging from stage one, stage two, stage three. Look for your commas, look for where you're not putting in things well. Okay, that's that. So yeah, somebody talked about round. So we have been seeing if we run an average, if we look for an average amount, let's say we carry this and we put it here and we run this query without this and select average amount. Select if you run here, it will calculate the average, but it should give us the value in a lot of decimal points because it's doing normal maths. So that's why we can introduce the round function. The round function is used to control decimal places in numbers. So the way it works is that you just round it to the number, decimal places you want it. So with this now, instead of me to just write select average amount as average amount from transactions, in front of it, I put the round function in front of it. Then in the bracket, I put how many decimal places round into. So if you run this now, since I say it's two decimal places, it rounds it to two decimal places. Any number I put it as, if I put it in zero, it round it to the whole number, rounds it to the whole number, which is sometimes might be what we're looking for most times. Yep. It is okay. So let's just leave it at one decimal. Yep. So that's what the round function is. Just put it in front of what you want to round and remember to put the decimal places. This is the syntax: round, number, and decimal places. This is it. Round what you're rounding. You're rounding the average now. Around the sum, around the total, around the max, around the minimum. Then you state how many places. This is just my alias. I can put it. I can decide not put it. If I don't put it, you're going to give me the results. So it's give me the whole result as this. This top, but that's not how I want it. I want it clean. I want the results clean. Good. So just do it like the same thing with revenue. The revenue was in values. You can actually run this to run the revenue, all the revenue itself to two decimal places. All of them are users to two decimal places. You can also use round in percentages. When looking for percentages, maybe like something like conversion rate. How do you look for percentages? You count everything. You know how percentages times 100. Percentages, you find the percentages, you say 40 divided by 100. So, and find the percentage of a whole. You're looking for a percentage of 40% of you our users. If your users are 2,000, then you want to look for 40% of users. It will be 40 divided by 2,000. Please, if the call ends again, you guys should just rejoin the link. Well, it will be 40 divided by 2000 times times 100. Yeah. Let me go and let me just end it and restart it again. Oh, okay. Okay. I didn't know. Is everyone here? At 12. I think we're 18 or 19. 12. Others are still trying. I think the other link just expired. Don't even go again. Get it. Mhm, mhm, mhm. Okay. Uh, everyone here. Let's see. Getting it. Okay. Name the rest. Struggling. Okay. Yeah, we were at I was planning round 40 over 2000 times. 1 over 4. Okay. So this is how generally we look for percentage. Math formula. Percentage. So explaining putting this now, let's say you're looking for a percentage in SQL, this is how we write it. Let's say you're looking for percentage of users of transacting users from our all our users. So what we did here is we counted we count all the users in the transaction table, which is transactions T. And so we use distinct T user ID. Then we see divided by percentage of users in the users table, counted it. What we just did here, we when we divided it. And one thing you should note when you are doing percentage in SQL, it's different from your normal board mass. You know, in your board mass, the way you write it, in normal math, they'll tell you should bring the division first before you bring the multiplication. So I had to bracket here. But in SQL, just remember that up you are multiplying. You are multiplying, then divide it by here. Yeah, that's just actually anyway, you always get it because you need it, you just need it, hand it to you. Then what you just did was we rounded the whole percentage. Now, rounded everything, put it rounding, put how many decimal points. So now if you run this, you are 69%. So now from here we know that 69.8% of our users did transact are in the transaction table or did transactions from all our users. I don't know if that's fair enough for us to grab. Yes, please ask. What's it divided by 2000? Yeah, what I was doing was I was just trying to explain the formula. Yeah, what I was trying to say was that if you know the way we look for percentage, you're looking for percentage. So for, like say we want to know, um, let me use like 1/2. 1/2 is half is 50%, right? But how do you find the half is 50%? 1/2 times 100, right? Yeah, that's 50 is equal to 50% now. So that's what I'm explaining. And in SQL now, if you want to write this 1/2 times 200, and in the context of okay, we want to find percentage of our users who have done transactions. This shows, let me write here. This shows the percentage of users who have done. So what does this show? So what do you do now? We count all the users we have on a transaction table. I will just count the user ID. And we use the distinct count because we want to count one user as once. Then we multiply it by 100, which is this 100 here. Then we divide it by the count of all our users in our users table. So that's why you see this u.id. On our users tables, our user ID is ID. This U stands for users. If you look at it from here, we did the alias here. Users U, transactions T. Anyway, you see T, it means the user's ID in the transaction table, count all of them. We count all the users' ID in the users table. Then we divide it, which is just like this divided by this times 100, which is the way I explain it here. So which gives us a percentage of our transacting users from all our users. Do we get? Do you get it? Which part is confusing you? Okay, what? No, let me make it simpler because if you watch the video, you might not understand it. If I don't clarify you personally. So what happens is that you have your transacting users. It's definitely not all your users on your users table that do transactions. So you have a table where you register users. You have a table where you register users that are doing transactions. You get me? Yeah. So now let's say you acquired 10 users in January. Then out of those 10 users, 5 of them did transactions. How many percent is that? Did transactions, which is that's 50%. So that's what we are showing here. So, but here now we don't know. So we are just trying to see how many users did transactions. Yeah. And we are looking at it as a percentage. So we call that a conversion rate. So this is conversion rate of our users that we acquired to those that did transactions. So what we did here is that we counted the user ID because on the transaction table we have user IDs. Yeah, we counted the user IDs of all those who have done transaction. We counted each user once, which is how we use distinct. Then we now go to the users table too. We counted all the users ID on the users table and we counted each user once. Understand? He still maybe. So what this place is just doing is getting a percentage for us. Getting a percentage for us. So we just count user ID on the transaction table, count user ID on the users table, use the transaction and divide the user, which is five users. For example, 5 users, 10 users we acquired, 5 users did transactions. So we are just dividing it. Then we rounded it. Then we now got that 70% of our users actually done transaction. Okay, I think this is the last thing we'll deal with. Okay, CTEs and views. Right almost. Yeah, that's just like it. That's just it. The first part is users who did transaction. Second part is total users on the uh, database. That's what somebody just explained in the comment. Thank you very much. Okay, so the next one is CTEs. Yeah, this is another thing that you would need to know when you are going advanced. These are advanced queries. CTEs are used. They are called common table expressions. What it does is that it lets you create a temporary result that you can reuse in your query. So, instead of using, there are some places instead of using joins or using subquery, you can use a CTE. Instead of using join or a subquery, you can use a CTE. Yeah. Don't worry. Just once I'm done, I'll pick you up this weekend. So there are some places that instead of using joins or using subquery, you can use a CTE. One thing with CTE is that it makes your query cleaner and it can make you know how to handle it. And once you start going advanced, and one thing is that it's very good with performance. CTEs are very good in running smooth queries. It's good for to scale. It's good for performance, and it's good to run cleaner and readable query. So instead of it lets you create a temporary result that you can reuse in your query, it's like a cleaner, more readable subquery. So instead of using to do all those brackets and everything, you can just use a CC. So how it works? Basic structure. The basic structure is just that you call the CTE first with CTE name as this, write your query inside the list. Then from that your query now, you can run a lot of query. You have already created the CT, the common table expression now. You can run as many query as you want to run just by from the CT you have created. For example, now let me explain with an example. For example, now you have your high level transacting users. Let's say the manager told you that okay, our users, that spend from 300,000, yeah, we call them our high value users, and we call them our high value or high value users. And yeah, we call them our high value users. Now, you want to create a CT, a common table expression, and call it high value users. You now say with the way the common structure is with CT name as which is with this is where you name your CT with high value users as now write the query you want to. So this inside here is the same thing like was inside the subquery that we did. Okay. So with high value users as select star from transactions where the amount is this, you have written your this alone, your CTE now. This now is being stored inside this as a temporary expression, temporary table, that you can still reuse as like with was in this same query. I don't know if I'm using you, I'm trying to refine you. Thumbs up or thumbs down. Okay. Thumbs up or thumbs down, others. If I have you, I'm always looking for a quorum. I get like 5 people. If you don't understand, thumbs down, no, so I can go, go over it again. Okay. Thank you. Okay. Yeah, I'll do an example. This already is an example. This already is an example. This is like an base example. So what you're looking for a high level, users now. So you now create a CTSA with high level users as select star from this. Then these are high level users now. You can get anything you want from these high level users. Let's say you know that you can say select star from high level users. So this high level users now is like a table now, just like saying select from transactions. But these are high level users now is a temporary table we created up here. That's why you can run any query inside here using select star from high level users. You can say select was it user ID? User ID I called Let amount. Yep. Let's run this. Yep. So now we know that this select user ID high level user from users from is only users that their amount is greater than 300,000. Let me use this so I can see if I can explain. Mm, normal, 300. Okay. Um, X. So this run this was they will run this. I'm trying to rewrite it in form of X. And instead of I can remove these high level users now, which selects. Please speak yourself. You can call here as high value. We have been saying levels. So see these two query. You see these two queries. See these two queries. This one, this query. This okay. See these two queries. They are doing the same thing. But this one is in the subquery format, and this one is in the CTE format. What happened? What is happening here is that we here in our CTE format, we stated the CTE first inside here with this as this, then you run this for us. You've already stated that let this query inside this box be called high level users. That's why you did this common table expression with high value users as this. You have defined this already. You run this from high value users that you've defined. If you're writing it in form of a subquery, you can write it like this. Select username amount from this. So most times you can use a subquery. Most times you can use a CTE. But in most cases, when you're going advanced and when once you're writing a lot of when you're trying to get a lot of things from from different CTEs, is more readable. It's more readable for CTEs are more readable. They are easy to maintain, and it's easy to debug. But the best choice depends on how complex your tax or the database you are using is. That's just one thing. How complex or how complex or the tax or the database is. But one thing you should understand that is that it's doing almost the same work that the subquery is doing. That's what the CTA is doing. But CTAs are very, if you go for if you can, most times they're always longer CTAs. If you are going for a technical interview and you see that at that place you can use, most times hiring managers are really impressed. Do some common table expression because it makes your code, your query readable. Another person can look at it and easily grasp what you are doing. Person that understands though. So that's just the basics of is CTA reusable. When I mean it's yeah, when I mean it's reusable, when I mean it's reusable, it's reusable inside the query. Like now, anywhere if I'm writing, if I'm still looking for some other columns now, I can still be referring to this from high level users. Don't even understand me. What then is the lifetime of it? So what it actually let me there's the reusability you should understand. I don't know if you got me, if you understand what I said. It means within this single query, that's the reusability we are talking about. You can reference it. You can reference it multiple times as if it was a real table. Do you understand? You give me a thumbs up. Yeah, the person that asked the question, do you understand? Okay, okay, that's cool. Yep. So um that's one part of it. Then let's if you try to look at another another example with this one now we are stating user revenue. You are calling let our user revenue be this. Just imagine it like that. Let our user revenue be this is what we are looking for. We're looking for all the users with the sum of the amount as revenue from transactions in the group type by user ID. Then now from this city now that we want to get just all the users with from the user revenue where the revenue is greater than 400,000. Already we have this information inside here. So it's just for you to query this out of the information had here. Most times it's always a Boolean tax, and a Boolean tax you'll be able to explain it in a grammar that you might understand. But I think I'm trying to make it simplify it so well that you will understand what I'm trying to portray. The other part of it might be you just looking at it from different. If you look at one, two, three other people, maybe read about it a bit, you will understand it better. Understand it better because writing code not easy, or writing queries not even somebody to teach person how to write. Nobody teaches you how to write. Just tell you what all the functions are for, tell you how you can use it, the use cases you can use it for you now to look at. That's why I say you learn how to write query by writing. So the best explanation I can give, if you don't understand, just understand the foundation. Okay, what is it really used for? What are the use cases? Okay, then from there you can actually looking for applications of okay where to use it and where not to use it. Best case, you see CTE can help you best case scenario in cohort analysis. I think I was explaining was it still in this class? I was explaining where my former company paid somebody to do cohort analysis. The guy did it on Excel and it took like almost 2 weeks to give us And I was like, this thing that we can use CTE and write it under 1 hour, 2 hours to get the whole result. Why are we paying somebody to do a month's job for us? They should add that money to my salary. Let me if they are really looking at a way to spend money. Because at some point, I discovered the guy was just company just gave the work to a junior level. Because at the end of the day, with CTE now, this was just it was a cohort analysis. What was the question? The question was that we want to see our users that we acquire each month, how they spend over the month. The users that we acquire each month, how they spend over the months. For example, users that we acquire in January, how much did they spend in February, how much did they spend in March, how much did they spend in April, how much did they spend in May. Users that we acquire in February, how much did they spend in March. So now instead of to put it out as months now, we're putting month one, month two, month three. So that helped us to understand when we acquire users, do they spend more in their first month? Do they spend more in their second month? Do they spend more in their third month? And if they do, which months of users did we acquire that spent more in their first or second or third month? And I was just like, when I looked at it, I was like, okay, what I can do for here is let me get right CTEs for the users table. I wrote CTEs for the users table, wrote CTEs for the transaction table, wrote CTEs for the months table. Then after my three or four CTEs, the remaining table are easy to get my cohort analysis table. I just say, okay, select from this table users, select from this other table, those that did transaction, join it to the other one, and under 1 or 2 hours, written at least 50 to 60 lines of query, and your result is out. You present it, and somebody's taking almost a month to do it for about almost 2 million naira is what they paid. Very furious. But I could not talk. Companies sometimes do funny things. So those once you know what you are, once you understand the context, understand what to do, you can actually say, okay, let me use this to get this. We have internet. But thank God now we have AI. The times when there was no AI like this, we used to use just normal Google or Stack Overflow and all those kind of things. But now there's AI. You can ask, okay, I have a users table. How I want to get this thing. How do I go about it? But most times, understand the foundation so that you know if what AI is giving you is right or wrong. That's why we are here. I don't know if I've been able to explain a bit of, giving a bit of knowledge what CTEs are for. The explanation is kind of up here. A bit of an explanation. It lets you create a temporary result that you can reuse. So it's just like the inverse, like the not the inverse. It's just like you changing where subquery is a cleaner version of a more readable version of subquery that is reusable in the single in still in this place. So if we run this now, do this. Yeah, this gives us it let us select the user ID, the total amount as revenue from transactions, group them by the user ID. So now we give all the users, all the transactions they made, we group them. Now we are selecting those with revenue greater than 400,000. That's just what that gave us. Okay. And another thing you can do, we can do is that if you have done a user table, then you do a transaction table. You can even put the maybe say, let me just see if I can do something. Okay, on my time. Mhm. Try to get an example. Just doing what I want to. Okay, let me use this. Yep. Okay. Let's use something like eh, okay. Now see this example now that I just pulled out. Just pulled out. Now you see our first CTE. You can use multiple, like I said, we can use multiple CTEs. See this first CTE. What's that? All ends soon. 30 minutes. No, just before. So now we get with user ages. Now we are getting a user age. This one, it calculates, this CTE1 calculates age for every user. With user ages as, we get the user ages. Select user ID, name, time, year of death, current death, and age. See, now we have brought in our age here, our user ID. So now in this table, in this CTE now, we have gotten the ID, user ID, gotten the username, gotten their age using this. Now do another CTE. This is the first CTE ends with a comma. The second CTE you will not use with. This with covers all of them. With user ages as this, total spending as this CTE to calculate the total spending per user. Now total spending now you put it as these are comments. Remember, these are comments, inline comments. With second CTE now, total spending as select user ID, some amount from transactions grouped by user ID. Now we have two temporary tables. Now the final query now that can join both CTEs together is now from these two tables now, because you want to combine information from here, information from here. You want to combine data from here, data from here. You want to combine columns from here, columns from here. So you now say, okay, select this UA.name. UA now was what? UA now is the user ages. User ages, which is this first CTE. This way you put UA.name. You now join the total spending and the user ages with your where condition now. Then you now order by this. So this is the query you are looking for. But for you to be able to query get this query, already joined two tables, or you already defined two temporary tables. So these are the great scenarios where you can use your CTEs, and it's very, 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 it's very clean for you to write. You know that you know the information you got here, you know the information you got here. You can join both of them on something and get your final query. You can state as much as multiple CTEs just to get all the okay, you need data for this, you group it and put, you get that one and keep, you get this one and keep. Then your final query now can be a connection of all the CTE you have gotten just to get the information you need. I don't know if it's okay. If you have an idea of what I've explained, guys. Do we get? Okay. I think I will put this under. Okay. So the last thing we are going to learn today is views. What views does? Somebody was asking me that time, can we not write a query and keep it and be using it? And I said, yeah, we'll come to that. The last thing we are going to learn this night. A view is a saved SQL query behaves like a table. So in CTEs, yeah, once you create that temporary expression, only use it in that single query. But for views, it's a saved SQL query that behaves like a table. Think of it as save this query and reuse it anytime. This one now saves it for you inside your inside your database, but it's only for you to see it. Only you that is working on it that can see it. Except you send another person saves it somewhere. You create a view, you can actually create it, push it for others to see it, or you can just create it and it's stored in your own part, so you can use it anytime. So you can create a view and keep it and be using that view as a table. When in where my present company, when we started, there were some I didn't have access to production database. It was a tug of war because it was why I could have it, because we have data engineers that they'll say, okay, the data engineers are there and actually create any table you want and send it to you. So what the data engineers do then is they tell me what and what do you want. I say, okay, need users, our users table. I need it like this. Need users that did this, or users that used our coupon, users that booked within this. They will go create, write the query on their side, create it as a view, and share it with me. So what I will just see is that view they have created. Think of it as a kind of transformed table based on information from others. Because database can be so big and you get confused. It's many people that have been are familiar, maybe people that created it or are familiar with it will tell you, okay, if you need this particular thing, go to this place. When this one joins with this one, this you need to understand very well database structure, that particular database structure before you can start querying. Else, you would making errors, making errors. I remember in my former company when I hired a junior data analyst, hired a junior data analyst. The guy tried to be faster than himself, He went and started. I gave him access to the production database because we had a backup. The production database was like kind of a backup. I gave him access to that. That okay, run your queries here, and when we need any ad hoc information, give us. So the guy was like kind of faster than himself. He went to he tried to do an analysis, very quick analysis, just to show that okay, I know the work. So you don't need to impress me on that for your first or second week. Already, I'm the one that interviewed you. I know what you know. So he did it. He said he brought out a kind of analysis that these are the people that did transaction between this time and this time, this peak period. And he said he didn't send it to me. He passed me and sent it to my boss. My boss sent it to me. Have you seen it? I said no. He said, okay, that I should look at it. That the my new hire sent it to him. I was like, okay. I'm not the first thing I told my boss that it's not correct. I was like, you not even looked at it. I said, yes, I know it's not correct. Before I even look at it, I know it's not correct. He was like, why do I say? I said, because there are conditions in the database that he doesn't know. And I'm sure he didn't use it. I was like, okay, just look at it. And I asked him, then you should have sent it to me. Let me reference at least. You are not strong, you are reporting to me. Why did you have to go send it? It's not done. I was like, okay. So he now sent it to me. An answer in that our database, for you to be able to say a user transacted, there are some conditions you will call from columns in the database. For example, for it to if you can say user that transacted, but the transaction is for another purpose entirely, and that purpose is not signified in the users in the transaction table. It's in another table, so you have to go and join with that table. And he didn't know. Sorry, I told him that this transaction, this amount is too big. Because my boss was like, it's too big. I say, yeah, because there's a filter I didn't use. So one thing with database, you have to understand the structure, understand what you need to add. For my present company now, if I cannot just go and say, let me get users that did bookings. No, there are some clauses I need to put. Their payment, especially their payment method. Because there are people that the way they design database, if a user just pays maybe 1% holding fee, is categorized inside the user that has made full booking. And that's not what we're looking for. We're looking for users that have paid complete. So we always put that clause that the payment must be complete. Somebody that's not studied the structure of the database now, you wouldn't know. So most times, if you are being given access to databases, be very, very sure that you understand all the conditions. Get close to the person that designed it or the person running the show and tell him, okay, if I want to get transactions, are there any things I need to know? A lot of times there will always be. What I'm telling you is based on experience. It's not just one place. That's happened everywhere that I worked. So you not just say, okay, I'm looking for users that did transaction yesterday, and you just say select star from users that did transaction yesterday. You can get it all wrong. It's the database person that will tell you, okay, for transactions, we don't look at this. This is what we call transactions. And they might design it differently from what business is saying because they are designing it to suit the technical parts. And trust me, it's from the business requirements they used to design it. So if you not understand the dynamics and the techniques and everything that was filtered or every table that is stored somewhere that you don't see, you will get it all wrong. I don't know if I'm making this point I'm telling you now is based on experience, things that you observe while you are working. Always see all these kind of things. And somebody doesn't tell you from beginning, you wouldn't know. Wouldn't know. Not see what you are doing on tutorials and everything is not what you see inside not what you see inside um the work. Oh. What you see in the work might actually scare you sometimes. What you see in work might actually scare you. It definitely is a very good foundation. It's what you see, but what I'm thinking when I mean not what you see, not like everything. Somebody's getting scared already. It's not like it's not everything you see. What you see, the experiences you get inside the job, it's it's a different ball game sometimes from what you see on tutorial. So everybody comes on tutorial, gives you clean data, and that's why they gives you clean data and tells you you do this, you do this, you will get this. When you go into a database, it will be so messy that you will use 3 days to be cleaning data, 1 day to be doing the modeling, then the other 2 hours to do analysis. Telling you the truth, you use 3 days just to clean and structure your reports. Then you use 2 hours to do just the analysis. But anybody that doesn't know wouldn't know the work you've put into. So it's all these mistakes, errors. That's why sometimes I play around, make errors, make you see, understand, like just like okay, I'm in a work system because the way I'm talking to you guys, and I'm like, okay, I'm in a work system. This one is giving me this. How can I do it? How can it? You are seeing it, and it's giving you a real life scenario of what you will go through. Okay, I get my sermon is okay. Feel like sounding like Jesus now, preaching on the mountain. But I hope we can actually get what I'm trying to portray. Okay, so this is our last. So I think we have just that was a good talk. So we our views are used. You can save this view, like I was explaining. They saved the view for me. I could see I could use the view and run queries inside the view. It helps you from actually always coming to do things a lot again and again and again and again. First scenario that I did, our user table was almost 91 columns. I think I can still remember. It was always a very long with columns that we don't even need. It's about 91 columns. Then in this 91 columns now, if I say if I need some columns, there are some key columns I used to need. In those key columns, I need them almost every time. For example, my boss will just say, send me in an Excel file, list of users. If I want to be employable, is it a must that we understand all this or we get to understand it go forward? Sincerely, let me tell you something. See, I'm telling you this for free. In the tech ecosystem, everybody, trust me, everybody is packaging. See, I'm not trying to people know what they are doing. But to be very sincere, you see this imposter syndrome. Imposter syndrome will come one way or the other. You just enter a place and you feel like you don't know anything. So you can never know, and you always forget. Because the more you are learning, the more you are forgetting. And you have to, that's why you need to take it. Right? If I was a banker and I go to the bank, if I go to bank today, I know that I'm just balancing accounts. I balance accounts. I go back tomorrow, I balance accounts. I go back next tomorrow, I balance accounts. I work from 9 to 5 as a cashier. It's very easy for me. But you see, tech, it's not like that. So tech is as everything is coming out new, you are moving. because a lot of stacks take data stack are coming out now. DBT now is on the roll. Everybody are trying to move. In short, Snowflake, Databricks, DBT. Most of them are trying to converge. Okay, this one is doing the same thing. This one is doing, because everybody wants to be in the system. So you can never understand everything. What I used to say is get the foundation. Get the foundation. It's very easy for me to talk to 13, 14, 15, 20 people. That's why from beginning I just needed 20 people, because I need people that I can actually say, okay, let's do it this way. Yesterday I was telling somebody how to apply for jobs on LinkedIn, and make them call you, make your CV seen. Those techniques I cannot give it to 435 people. Trust me. But the best I can do, I can throw out the foundation to you. It's on this foundation you build. A lot of times you learn it on the job. You learn it better on the job. But for you to get the job, you need to have a foundation. You need to have a knowledge of it. But inside the job, learn a lot of things. The job will give you an experience. The job will give you an experience. The experience to be able to navigate. So, but just get the foundation. Be ready to, like, okay, I've gotten this. I know what I am doing. Then when you go into the job, all the arrows it throws at you, you can learn everything. I told somebody I learned about six different tasks in one company I worked for only 9 months. Like I learned six different. I learned how to do sales analysis with all the CRMs. Learned how to use marketing analysis tools, about three, four of them. I learned a lot in that particular, and most of them always converge in you understanding what you want, which is the analysis part of it. Then the tools become just a vehicle delivering your insight. I don't know if you understand, if I've answered your question. So you need to get the foundations to be employable. Know that, okay, you can actually look at the data, use your technical knowledge of Excel, Power BI, and SQL to get insights on the data. Then inside the job now, it helps you to grow, know better, get exposed to other tools, how reporting works, how the environment works, how better present data to your stakeholders. I don't know if I answered you, Ibuchi. Yeah, did I answer you? Are you satisfied? Okay, good. So, so that's what views. Let's go back to views now. That's what views are used for. It's a very simple syntax. You create view for this. So I was trying to explain how when we I use this. So I was saying that I looked at a user table. They were like almost 91 columns. And what I did was that I just created a view with the six, five, six most important columns I use every day, which were user ID, username, email, location, location, and referral status. I think about five to six, seven columns. I just created those columns and I stored this as a view. Stored it as a view. So anytime I needed anything from users, I know it's going to be within those 5 to 10 columns. I just go query it from there and it's giving me clean data instead of me to be querying almost 91 columns or query the whole user table. So I was only querying, I just saved the view as users view or view users, anyone has anything saved users. Then I'm always running my query from that particular view. So views are stored queries that can be used at any time and it's inside your database. For example, let me say I'm creating this view now. I want to create a users that have high high value users. So I create this view and it's stored in our database. So anytime, and then let's say they might just tell me if I create this view now, let me use it. Let me call it high value users or high value users transaction. This view now, if I run this query now, that show me like that's created this view. Now, anytime, hmm, anytime I can run this. Okay, let's first do. If I refresh here, you can see it's not here. Not sure. The only one the first one I created. You always see your views. This is the DB I'm using my DB. If I refresh here, Press share. Then I go and expand my views. You see, high value TX. See all the columns it has. Just created this view now. So this view now is stored in my views, and I can run a query on it as if it's a table. So now I can just say select star from high users X. I can run query on that now. Even me anywhere as far as that view is saved, and I can use it as a table. So I just know that anything I'm running from here now, it's only returning information of users that have transaction with above 300,000. So okay, another scenario where I used this was that we're trying to get users that are users that are booking very much a particular value. I think we set $12,800. Okay, these users that we actually want to be using for different things. I just created that view. I joined their details. I just went to the users table, collected some of the details I needed, then joined it with the transaction table of how much they have spent. Then those that are spent above 300,000, above 12,800, I saved it as a view. So anytime they needed information about those users, I always check it from the view instead of to go and start writing my joins again. I always check it from the view because I have that view. I know that that view is always needed. This information is always needed. I just created a view and kept there. Added the columns I wanted from different places, from different tables, kept it there. So they just say, from that are high level users, how many of them even use coupon? How many of them even use our referral bonuses? Just go straight to the view, query on it, check how many of them use coupon right from there. It gives me, instead of me to go and start writing long codes that will join coupon, join loyalty. So I have the view saved already. So you just do it with create view. If you now, for example, I needed a customer and transaction summary. Views can be used as summary tables. You learned how to create summary tables then in Excel. So I can just say, okay, I want a summary table of my customers and their transactions. What's the summary table now? Select the user ID, select the user location, user user location, which is residence country. Understand? You select the from the users table, select the transaction table. Yeah, I'll end the class now. Select in transaction, then you create this as a view, keep it. Anytime you want to get any information from the customers and transaction table of the summary, you get it from that view. The view will be saved. So that's just for, I don't know if you have any question or any comment. So what I'm going to do for then, I'm going to share this full sheet. We run through it, and I'm going to share this assignment sheet too. So what I need from this assignment is anything goes like every question is business assignment, data set, users and transaction, which is the same data set. Just on write this SQL query under each question. Do not modify the questions. So section A is customer insights. And they say the marketing team wants a full list of importing of file is on the other part. So this one is just analysis. Okay. Civilian. Ooh. Oh, you know what you do? Send me a link on Telegram. Send me a link on Telegram if this class ends. Send me a link on Telegram. I'll join it. So what you just have to do is customer insight. Okay, this is sorry. The marketing team wants a full list of all customers. Understand? So how do you get a full list of all customers? You write a query to retrieve all users, which is so you just write the query down here, select the users. If once you run it, your query runs and it answered the question, just leave the query there. Go to number 2. You say, what do they want? The company wants to know where customers are located. You have your user ID. It's telling you now, okay, they just need only the user ID, country where they are located only. Write your query. So I think I have about 48 of them. Just simple queries and a little more advanced that you can write. So you will do this. Next week we'll have our feedback session. You don't need to rush it. Once you finish it, submit it